the last thing, the last thing that we have left in this unit, so we talked about ecology, the science of ecology. Then we shifted in last week at the end of the week. We talked about how humans are impacting the environment a little bit. We just talked about some general things. Resource use, human population growth, which leads to pollution and overuse of resources. The last section of this unit is just to talk about some specific environmental issues, okay, that humans are responsible for. And so we'll talk about a few of them. And you should just know sort of the basic cause. What is it that humans are doing that causes each of these problems? And then what are the effects? How does this affect the earth, the ecosystem, and so forth? So one thing maybe you've heard of is acid rain. Probably better termed acid precipitation, because it's not just rain, it also includes snow. Now there's something you have to keep in mind. When I say the word acid, you think of like something that's going to like melt your skin. And there's a property of materials called pH. That's the scale that we measure how acidic or basic something is. But it has a wide range. It goes from 0 to 14. And so some things, yes, can burn your skin and melt through materials, but some things are acidic and they don't do that. So it's a range here. So we use this pH scale to measure acidity. Now, it goes from 0 to 14. 7 is called neutral. It's like pure water has a pH of 7. Okay? So it's not acidic, it's not basic. Distilled water is 7. Now, rain that comes from an unpolluted source is a little bit acidic, 5.6, because there's carbon dioxide dissolved in it, and that makes it slightly acidic. But again, not acidic in that it causes any problems. It's just a little lower than neutral, 5.6. You can see as we go through the pH scale, wine, for example, is a little more acidic. Or lemon juice, orange juice, those things are acidic. Again, it's not that you spill orange juice on you, it's going to burn your skin, but it has a lower pH. There are things like battery acid, which are very low pH, 0 or 1, which are very dangerous. That could burn your skin. That's why, if you, if ever your parents spend like jump starting your car, if your battery dies, you put the jumper cables, you're supposed to protect your eyes in case the battery, there's acid in that battery that if it got on your skin and your eyes would damage them. So, normal rainwater is 5.6. However, when humans burn fossil fuels, like coal especially, it's high in sulfur and nitrogen. When these compounds get in the air as you burn gasoline or you burn coal, they combine, these sulfur compounds and nitrogen compounds combine with water in the air and make sulfuric acid. And that changes the pH of the water from 5.6 to lower, 5 or even sometimes in the 4s. And that is too acidic for many organisms to handle. Okay. So we get more acidic as we get a lower pH. And so what happens as this rain falls in ponds, in lakes especially, those areas store up water. And if they're storing up lots of this acidic water, it can end up damaging fish in those mussels, invertebrates, plants. And so it can damage them. Lakes can become acidic. There are some lakes that are called dead lakes. They have become so acidic over time that nothing really can live in them any longer. And so they look very clear, and you may think, oh, that's very clean water, but actually it's clear because there's no organisms living in there. They can't survive the acidic conditions. It's especially a problem like in the Adirondacks. Because of the soil type, they're not able to absorb much of the acidity. And so it's especially a problem there. Also, it's a problem during the spring because you have in the winter the buildup of snow that may be acidic, And in the spring, it all melts and flows into rivers and streams and lakes, and that sudden drop in pH can damage different organisms living there, right?
Isn't there a lake in Syracuse like that?
Oh, Onondaga Lake? Yeah, you may be thinking of that. They're rehabbing that. It's not due to acid rain, though. It's due to other types of pollution from industry that used to be built along the lake. So this can lead to dead forests, lakes, etc. This graph here on the left shows sort of how different types of species are affected by acidic conditions. So this is an aquatic ecosystem, a water ecosystem. At a pH of 6.5, all of these species are able to survive and live. Okay, mussels, bass, mayflies, all the way up, all these organisms. But as the pH of that body of water starts to decrease to 6 and then 5.5, well, once you get to 5.5, the mussels can no longer tolerate that pH, and so they start to die off. If we go a little bit lower to 5, again, the mayflies and the bass can't survive. And so each time when we eliminate a species, we know from a food web there are implications on things that eat that species, on its prey and so forth. So it interferes with the functioning of that ecosystem, and salamanders and then lake trout and so forth. So when we get to these real low pHs, there's very few organisms that can survive and tolerate that. Now if we look at this map of what country? Yes. So we see this, the colors indicate basically the pH measurements. Green is sort of a higher pH in the 5s, mid-5s. That's non-acidic conditions basically if we're talking about normal rainwater. And so we see where is this mostly a problem? This problem of acid precipitation. Right? On the east, especially in the northeast, in our area. And part of that reason is that the Midwest here, northern Midwest, there's lots of factories and so forth that release pollution in the air. But because of the way the winds, the prevailing winds are in the United States, they generally blow west to east. And so a lot of that pollution that's put into the air in the central areas of our country drifts over to the northeast and ends up falling in the northeast, which leads to acidic conditions in the northeast. Here's some examples of how acid rain affects things. You know, here we have a spruce forest. Some types of trees and plants are affected more. Spruce are very affected by low pH conditions. So this is in Maine. This is a forest in Maine that the conditions have become too acidic and the trees are dying. This shows tree ring growth, okay, throughout from the 1950s, and you see that these trees, the amount of growth in a season is decreased as these conditions have worsened. If you ever sort of walked around in a cemetery and you notice older gravestones, the kind of whitish colored ones, often if you look at them, the words are completely eroded or barely visible. It's because these old monuments were made of limestone. And when an acid interacts with limestone, it breaks it down very easily. And so they weather very quickly with these acid conditions. You can see, you know, the statues. This is a statue. I believe this is from Central Park. This is a statue, a picture taken in 1908. And this is taken in 1968, 60 years later. You can see the features have been completely eroded from that face due to these acidic conditions. Any questions about acid precipitation? Smog is another important environmental issue. Now, this is not with an AU. This is not the giant dragon from Middle Earth. This is smog with an O. Okay, and smog is a word that comes from the combination of smoke and fog. It's a pollution-based problem. And it comes from the emission of ozone gases at surface level that interact with sunlight and they create this ozone, this pollution, kind of settles in certain areas. Here you see a picture. It shows Beijing, China, on a day when there was not smog it's dependent on weather conditions, when it settles in a certain area, and then when there is. This is not fog, this is pollution in the city. So this is not a good situation. And it produces this toxic gas that's dangerous for living organisms. It's especially a problem with lots of cars, because cars release the chemicals that form smog. And it can be dangerous. Can result in respiratory problems. If you lived in an area where smog was a common problem, on the morning weather report, not only would they tell you the temperature and whether it's going to rain and the humidity and stuff, they may also give you the smog index. Because if it reaches a certain level, there will be a smog warning, and they'll tell you not to exercise outside, because they don't want you to inhale a lot of these pollutants. People with asthma should stay inside, and so their asthma is not affected by this. There are ways of helping treat this problem, and it has to do with sort of reducing the pollutants coming out of cars and factories and power plants. If those emissions of these compounds can be reduced, then we can reduce the amount of smog. And sometimes there's different sources of fuel that produce less of these chemicals. There's certain equipment on a car, like if you've heard of the catalytic converter on a car, that helps remove certain pollutants from the emissions of that car. Right?
Is that like global warming?
It's a different issue, which we're going to talk about in a second. What's that? Oh, reduce emissions. You can reduce the emission of these chemicals. All right, our last couple are two environmental issues that are both important, but they're often confused by students. Students often mix these two up and think that they are related in ways they are not. The first one has to do with the ozone layer. The ozone layer is a layer of gas high up in the atmosphere, the very top layer. Does anybody know what the ozone layer does? It's very important for us. In fact, if it weren't for the ozone layer, there may not be life on Earth. What the Ryan?
Keep radiation from
Yeah, it helps to block certain types of radiation, ultraviolet radiation. Do you know what ultraviolet radiation does to our bodies? Maya?
It affects your cells, I think.
Yeah, it affects your cells. And it can damage cells. Generally, it's our skin and our eyes, because they are exposed to the most ultraviolet radiation. Ultraviolet radiation will cause you to get a sunburn. Okay? And the ozone layer is energy from the sun, goes through space, and enters the Earth's atmosphere. This layer of ozone filters out much of the ultraviolet radiation, so not as much reaches us at the surface of the Earth. Very high in the atmosphere. The problem is that it's being destroyed. The ozone layer is being thinned out by certain types of chemicals that are called CFCs, chlorofluorocarbons. These CFCs, when they get up high into the atmosphere, they destroy ozone. And so the ozone layer becomes thinner and not able to block enough ultraviolet radiation. These CFC chemicals are found in, they used to be found in a lot of aerosol cans, like a can of hairspray or something. They're no longer used as much for that. They're found in air conditioning units, in refrigerators. And what happens if we have less of this ozone layer, more ultraviolet radiation is reaching the surface of the Earth. That could lead to more skin cancer and more cancers of the eye and cataracts. I'm sorry. Antarctica. Okay? And that's where many of these gases accumulate. This is 1979. This is 2008, and this area shows lower concentrations of ozone. There was a hole in the ozone layer over Antarctica, letting in much more of this ultraviolet radiation. Now, we've since stopped using as many of these CFCs, and so the problem has actually been improving a little bit. Okay. So that's ozone depletion. And then our final environmental issue to talk about is a very important one, global warming, or we might hear it called climate change. You know what causes global warming or climate change? Maggie? Yeah. Do you know which specific pollutant causes it? There's one specific gas that humans release billions of tons of each year. Maya?
Carbon dioxide?
Carbon dioxide, yes. It's caused by carbon dioxide accumulating in our atmosphere. If you imagine carbon dioxide, think of it as a blanket over the earth. Why does a blanket keep you warm? Put on like a nice thick blanket at night if you're cold. Why does it keep you warm? Abby?
Because it
Yeah, it traps the heat your body's releasing. It keeps it nice and close to you so you're nice and cozy. The carbon dioxide in the atmosphere basically does a similar kind of thing. It traps heat close to the Earth's surface. The thicker the amount, the more carbon dioxide, the thicker the blanket. Okay. And this carbon dioxide comes mainly from the burning of fossil fuels. When we burn fossil fuels, or other fuels sometimes, we release carbon dioxide in the atmosphere. And you know, we are burning vast amounts of fossil fuels, coal, oil, natural gas. And whenever we burn those things, we're releasing carbon dioxide into the air. And that traps heat close to the earth, warming up the earth. Now really, we've seen, if we monitor the carbon dioxide levels of the Earth's atmosphere, we see that they have taken a drastic increase since the middle of the 1800s. How come? When you graph them, they stay at a relatively constant level, and then they start to grow exponentially. Michael? Yeah, what did you call that in sociology? Yeah, the Industrial Revolution, okay? In which, hold on, let me get that up there. In which humans first started to use large amounts of fossil fuels to power factories and cars and other power plants. And as we started burning more and more fossil fuels, we started releasing more and more carbon dioxide into the atmosphere. And the Earth began getting warmer. Now you may say, well, so I like the warm. It's cold here in the winter. Well, it's not just that it's nicer, but there are a lot of negative consequences to the Earth, to ecosystems, to human populations. Because as the Earth warms, many other things happen. One important thing that happens is the ice on our Earth melts. Where's there a lot of ice? Antarctica, the Arctic, very northern, very southern latitudes. As that ice melts, it turns into what? Water. And that water ends up in our oceans. And so if we add vast amounts of water to the oceans, what happens to ocean levels? They rise. And that is a major problem for lots of people. Who is it especially a problem for? Maya?
Animals that live there, the ice is melting.
Okay.
Polar bears.
So it's a major problem for animals that are adapted to living in these Arctic conditions. They've adapted to life in very harsh conditions, and as that changes, then those organisms' habitat is gone.
Do people and animals live on coast?
Yes. So this is especially a problem for people, countries, towns, animals that live on low-lying coastal areas. Countries like Indonesia, which is basically a country which is a series of thousands of small islands. As sea level rises, those islands start to disappear. If you've been to Florida, on the coast, right, surrounded by ocean, there are lots of big mountains and hills in Florida. Pretty flat. What that means is a small rise in ocean level can flood a large portion of land. Also, storms, hurricanes, get their energy from heat in the oceans. As the oceans become warmer, the energy in those storms can increase. So the way this works is through this process called the greenhouse effect. If you ever, it's a sunny day in the summer, and you go in your car, the car's been sealed off, and the sun's been shining in the windows. You get in that car, it's really hot, right? That's because sunlight, the radiation from the sun gets into the car, heating up the car, but the heat cannot escape because the windows are closed. And so the heat builds up. That's the same thing that happens in our Earth's atmosphere. Sunlight can get in through the carbon dioxide, but then when it tries to get out, the carbon dioxide keeps it in, and the temperature builds up. We can look at examples of how this has affected ecosystems. We look here, this shows Arctic sea ice in 1979 versus 2005. Look at these areas on the left. Again, we have a lot more open water and less ice. Okay? That's because this ice that used to be here has melted. These are two pictures taken from the exact same vantage point in 1928. It's a huge glacier. This is all ice, all the way back into these mountains in 1928. You can see the line of where the glacier ends. In 2004, due to heating of the Earth, that glacier has receded. It's melted all the way back up into the mountains here. And what's in its place? Water. Okay. And again, animals that use this ice as their habitat, well, they now have much less of their habitat. Okay. If we look here at Florida, if sea level were to rise very high, this is a big rise. If all the ice melted basically on the Earth, this is the coastline of the southeast United States. It's green. Where's Florida? Gone. Almost all of Florida's gone. There's a couple islands here. Okay, you could see this is the coastline. Look, if sea levels rose that much, we would have this as our coastline. Now, where are cities like Boston, New York City, Baltimore? We have many of our largest cities, Miami, are on our coasts. It's great for transportation. People like living near the ocean. But if this scenario were to come true, those cities would be gone. Okay? So, it's important that we address this issue of global warming. And so you see, again, this is that same thing. You could see the shoreline. This is what the United States would look like if that ice were all to melt. See, all this section is all underwater. Okay, same thing. You can see South America. This is what South America would look like. And Australia. Okay. Antarctica.
Yep.
All right. So, by reducing carbon dioxide emissions, by driving more efficient cars, by using less fossil fuels, we can help to reduce this issue of global warming. All right, our final thing. And this is really belongs better in the ecology section, but this concept of tropisms. Plants are able to respond to their environment. We may not think of it, but they can. Tropism is growth or movement caused by a stimulus. And plants can grow responding to various environmental cues. You just have to fill in the causes here. Phototropism is when a plant grows in response to, anyone guess? Phototropism.
The sun.
Yeah, light. If you grow a plant near a window, the plant will eventually grow towards the window, grow toward the sunlight. Hydrotropism. Count 'em?
Water.
Water. A plant's roots will grow towards the source of water. Chemo. This is chemicals. Certain plants will grow toward or away from chemicals, towards nutrients that they need. Thermotropism. Eddie? Temperature. Heat. Some plants can respond to heat. Some plants, their leaves close up when they are exposed to heat to help protect them. Gravito. Eddie?
What do we put in your head?
Don't worry about it. Gravito. Found? Gravity. If you plant a plant sideways, after a few days, it will begin growing up, away from the force of gravity. Roots will grow down. Thigmo is responding to touch, like a sensitive plant or a Venus flytrap responds to physical touch. So we have those shown here. Venus flytrap, growing towards the light, growing towards gravity. Don't worry about those. There's some, I had some, oh, here's, will this play? Maybe not. Oh, yeah. Maybe it will. Venus flytraps are pretty cool. I guess it's not mine.
You should be able to look it up.
Yeah, I'll show you that maybe tomorrow. All right, any questions about our environmental issues section here?